So the pH scale starts from 0 all the way to 14. Anything under 7 is considered an acid. Anything at the 7, like water, is considered neutral. Anything higher than 7, then it's a base. Again, what is the pH? It's the potential concentration of the hydrogen ion in the solution. And by measuring this, we can, and know the number, we can determine if the solution that we have acidic, neutral, or basic, depends on the number we will get, or the pH we will get. Where did they get these numbers? So there is a way on how the scientists actually got these numbers. They found out. I will just give you a brief summary. You don't have to know all the details. Just a brief summary on how they got these numbers. They got it when they tried to measure the from this equation the dissociation of water in this equation here. So basically, if one water molecule and another water molecule, if one of them will give a hydrogen, one of them will be acid and the other one will be base, and then acid conjugate base, the other two on the other side. Okay, same as if we have a solution dissolving in water. So when they measure the concentration, they found that the values range between 0 and 14 specifically. So they said that basically the concentration of the hydronium ion, we call this hydronium ion, and it also can represent the hydrogen ion. So the acidity of the molecule, if the concentration is higher than 10 to the power minus 7 molarity, mole, then we have acidic solution. If it's equal to this, then it's acid neutral solution. If it's bigger than this, then we have basic solution. So let's practice these. Identify each solution as acidic, basic, neutral from their pH. So A, HCl with a pH equal 1.5. Acid or base less than 7, acid. Pancreatic fluid, the concentration is of the hydronium ion is 1 times 10 to the power of minus 8, which is higher than 10 to the power of minus 7. Then we have a basic solution. pH is equal 3. Then we have acidic solution. pH 7. Then we have neutral. The concentration of the OH is 3 times 10 to the power of minus 10. How much again? It's bigger than, where is it? Oh, I am here. Sorry. So it's acidic solution. The hydronium ion concentration is 5 times 10 to the power of minus 12, which is bigger than 10 to the power of minus 7. Then we do have a basic solution. So to determine if the solution is acidic or basic, basically we have to look at two things. So let's put this in here. So we either look at the pH number. If they said the pH, if they said which means pH is between 0 to 6. Anything under 7. Here neutral solution pH equal 7. Here pH is between 8 to 14. Okay, so you look at either this option or this option. If they give you right away the pH number in numbers from 0 to 14, then you just follow this chart here. If they give you, the question give you the concentration of the hydronium ion, or in other words, the concentration of hydrogen, or the concentration of the OH, then you follow this chart here. Okay. Calculations. Sorry. So this is the equation that we will use a lot. So the pH is minus log the concentration of the hydrogen ion or hydronium ion. Both can be considered the measurement for the pH. So straightforward, I will give you one information and ask for the other. We will just use the log, and we will use our equation. pH is equal minus log to the hydronium ion. So the equation here, or the problem here, is saying aspirin was the first non-steroidal anti-inflammatory drug used to relieve pain and fever. If a solution of an aspirin has a hydronium concentration ion is 1.7 times 10 to the power of minus 3 mole, what is the pH of the solution? So very straightforward. So you have this equation, right? Minus log the concentration of the hydronium. You will apply your number minus log concentration that they gave you. And this is how you need to practice on your calculator. Practice a lot on this until you master this. So you don't have a problem, because we will have a lot of these problems in the test. So just make sure you practice a lot, because it's very easy and straightforward. So, and sometimes this method doesn't work with all of the scientific calculators. So try to figure it out. Or even you can Google it, or you can YouTube it with the brand name of your calculator. So for this one, log 1.7, and then you press the button EE or exponent exp 3 minus plus and minus icon equal, and you will get this number. And by looking at this number, I could say that the solution is acidic, because pH 2.7 is acidic, in the range of acidic solution. The second equation, or the second problem, the practice. Find the OH of a solution with a concentration of 4.10 to the power of minus 5. Again, same thing. Our equation, equation that we will apply our number in is this one. pH is equal minus log the hydronium ion, which means minus log 4 times 10 to the power of minus 5. And on the calculator, you will do look for EE or XP 5 minus. Some calculators actually take it as minus and then 5. So you try both methods and then equal, you will get this number. Again, this number is 4.3, which is considered acid. Now we will flip it around. So again, our equation is pH equal minus log the concentration of the hydronium ion. What if I give you the pH and ask it for the hydronium ion concentration? What if in this equation, in this problem here, I told you that the pH of the solution is equal to 4.40. Find the concentration of the hydronium ion, which means find this one here. To do this, we can use this formula. Hydronium ion is equal to 10 to the power of minus the pH. So basically 10 to the power of minus 4.40. And then you will get the other number, which is 4 times 10 to the power of minus 5. Okay, so let's practice. Here, determine the hydronium's ion concentration for a solution that has a pH of 4.42. So again, the hydronium ion is equal to 10 to the power of the pH. To do this on your calculator, you will press on second, log, and then the number 3.42, and then plus or minus. Again, some calculator, you have to put the minus before the number in the order, and then equal, and you get this number. And this means time 10 to the power of minus 4. So this is the concentration. And you have this crazy chart here. This chart is basically to tell you how to use or which equation should you be using if you want to get the hydronium ion concentration, the pH, the OH, the POH. So this is, if you understand this graph, then it will be very easy for you to determine which is which. So for example, let's keep it simple and try to do this part, finding the H or the hydronium ion concentration and finding the pH. So whatever you will need to find out is at the head of the arrow. So for example, if I gave you the pH of 3 and asked you what is the hydronium ion concentration, then you will be using this arrow, which means you will be using this equation, which we just did. Okay, if the question is gave you the hydronium ion concentration and asking you for the pH, so whatever is needed is the head of the arrow. So they need the pH. Then we follow the arrow that point to the pH. So this one here is the right formula that we will be using. Here, if we have the pH and we need the POH. What is the POH? POH is the potential concentration of the hydroxide ion in the solution, which represent how alkaline is the solution. It's exactly like the pH, but the pH, the potential concentration of the hydronium ion or the hydrogen ion, but here is the potential concentration of the hydroxide ion in the solution. So if they give you the pH of 4, for example, or 7, let's say they give you the pH of 7 and they need the POH of the solution. So you apply this equation. So the POH is equal to 14 minus 7 equals 7. If they give you the POH and asking you for the pH, you use the other one. Any acidic solution has lots of hydrogen ion. Any basic solution has lots of hydroxide ion. This is as simple as